we're going to find the Lewis structure of the NO3- or nitrate ion. So following the stop everything, drop out method, we're going to start out with the structure. So nitrogen is the least electronegative. We're going to place that in the center and have all of our oxygens. Then you want to calculate the number of valence electrons. If you look at this periodic table of elements, we can see that there are 1, 2, 3, 4, 5 valence electrons for nitrogen and 1, 2, 3, 4, 5, 6 valence electrons for oxygen. So in total we have 5 electrons from our nitrogen and we have 3 oxygens which each have 6 valence electrons. But we can't forget that since this is an ion with a charge of -1, we also have to add 1 more electron to our valence electron total. So this is 5 plus 18 plus 1, which is 24 valence electrons in total. So on to the next step, we're going to distribute these on our structure. So we have our bonds here, then we're going to go to our terminal elements. Okay, and our last step is actually to make sure that we have an octet. So let's see, we have let's check for how many electrons we've distributed so far. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pairs of electrons, which give us our total count of 24 electrons. So now we can go to our step with the octet. Everything has an octet except for our nitrogen. So what we're going to do is we are going to make a double bond. So then nitrogen has its octet with 2, 4, 6, 8, and so do all the other oxygens. But if you look at this structure, how do we know which oxygen is supposed to have that double bond, right? Because in truth, this isn't the only Lewis structure that's possible. The other Lewis structures that you can have could be, well, let me redraw this. Could be like this with a double bond here on this oxygen, or like this with our double bond on this oxygen. And therein lies our dilemma. You can flip to the next slide to see what we can do about that.